All right, good morning, wonderful people. Let's go ahead and start today. Move on over to our lesson. So if you remember, we are going over the, so if you have your packet in front of you, we're going to be doing the second one, which is the page that looks like this, order of operations. So this is kind of a general review before we start the main Algebra 2 stuff. That way we're all on the same page when we go through. So the ones that we cover in class, remember those are what I call the in-class work. So if you were taking my Algebra 1 class, it's pretty much the same thing. Your in-class work is 5 points, but because of what's going on now, I'm gonna also make the in-class work part of your attendance. And the one you're gonna be working on, this is 10 points, is the one that says homework. Let's see, where does it say that? Right there on the top of the page right there. So that is the one that you're going to do on your own, and that'll be worth 10 points. So let's go ahead and get started with what we're going to be doing today, and that is to apply the order of operations when evaluating numerical expressions. So again, don't be confused. Just because something has math stuff on it doesn't mean that it is an equation. All right, so that's the common misconception that I always get, is people calling everything an equation when it doesn't have an equal sign. So if it doesn't have an equal sign, it's an expression. And simplify answers as much as possible when evaluating numerical expressions. So those are the two things. So before we can apply the order of operations, we need to know what they are. So let's just do a quick recount of which ones it is. So I don't know if I have a whole lot of people here today, but how many steps were in the order of operations? So I want you to think back to when you first learned this, which for most people I think is around junior high. So 6th, 7th grade, something along those lines. So let's say that there's a huge math problem. Let's say something like this. All right, so we got minusing, we got adding, we have division, we have exponents, you know, we got a little bit of everything. So what is the first thing that we do in that sort of case? So there's a little bit of a misconception here, and I'm pretty sure most people would say parentheses. Actually, I also have a little bit of a diversion here. Oopsie. We're gonna take a little break here and we're going to watch some videos. I mean, sorry, this is a video from today's sponsor.
Automatic freshness, softness, and static control has never been easier with the Bounce dryer bar. I just stick it to the inside of my dryer and I never have to remember.
Oh, Spice Body Spray makes you smell like power! It's so powerful it sells itself in other people's commercials. You smell like outdoor freshness.
You smell like power.
Yeah, I do. Power!
Anyway. Sorry, I should have shown that before. Otherwise, it would have had a bigger impact. So first step you do is you take care of the groupings. Now, I know what you're probably would have said is you would have said, oh, well, shouldn't you do parentheses first? Which is true. If you see a parenthesis, that is usually the first thing you do. But you know, there are so many more grouping symbols just besides parentheses. You have brackets, braces, and two of them that are oftentimes used but forgotten a lot actually are absolute values and fractions. Those are also things that you do first. So anyway, after groupings, what is the next thing you got to take care of? Exponents, power. Okay, like I said, it probably would have had a little bit more impact if I had shown that first. But anyway, there you go. So hopefully you don't forget it. All right, anyway, back to here. So exponents, and then multiply and divide from left to right, and then add and subtract from left to right. So if I ask most people, how many steps are there? You were probably thinking of 6, and there's a pretty good reason for that. And I know it's been drilled over and over so that you don't forget it, and it's usually PEMDAS. And there are some things I don't like about PEMDAS. It works, all right? It works 90% of the time. It works 9 out of 10 times. So it's not bad, but the thing is, there is so much more going on than just following those steps. So I'm going to show you some common things that usually go wrong when people try to follow PEMDAS. So if you look on your page, this is exactly what it shows. So I like this worksheet because it says grouping symbols and fraction bars and not just parentheses. So I want you to look at that top one for now. Just look at this top expression here. What's the answer? Think about it, think about it. I'll give you like 10 seconds to think about it. If you know the answer, you can go ahead and put it in the comment section down below and see if you got it right. Or you can use the chat as well and see if you got it. But I did this with my first hour, and luckily that a lot of them participated, which is good. And a lot of them, I think, said 2, I think is what they said. Now there's a problem with that because that is not the right answer. Well, what is the right answer? So I'm gonna go ahead and go first and explain what people usually do when they see this. So again, in their mind, they have this going on. And okay, so they see no parentheses and they have no exponents. But here's the problem. They're gonna look at this and say, ooh, M, that means I should do the multiplication. So they go 10 times 2, which is 20, and 40 divided by 20 is 2. So that was the answer my first hour gave me. And if I had a class, a large class, I will get some people saying 2, and I'll get some people in the, near the front or in the, or the back of the class sitting in the middle rows, so going, no, I don't think it's 2. So who is right? Well, again, this is what's going on in people's mind, and when they're saying, ooh, PEMDAS, P-E-M, ooh, M means multiply, so they do that first. But that's not really right. That is not actually the steps. So when I ask people how many steps are in the order of operations, they usually say 6. And 6 is not right. It's actually 4. There are actually 4 steps because multiplication and division go on the same step. So if you look closely at it, it says multiplication and divide from left to right. So I could easily write something like this, and it would still be correct. We could divide and multiply from left to right, but most people, well, I think it's because multiplication is a little bit more common, so they would say multiplication first. But again, both of these are correct. Although that sounds kind of like something scary, I guess. PEMDAS just sounds a lot more friendly. Your friendly neighborhood PEMDAS is here. Oh no, PEDMAS is coming. You better hide. Oh, man, that does sound terrible. Anyway, so the actual answer, again, starting from left to right. So we go left to right. So starting from 40 divided by 10, that would be 4 times 2. So the actual answer should be 8, not 2. So okay, I got someone in the chat saying, yeah, it's 8. But again, if I didn't give any sort of warning about what was going to happen, I think almost everybody would have said 2. And then I have another one here. You've probably seen it, so I might have ruined the little joke. This shape doesn't even cover that. So I probably have to reorganize that. So look at this second problem and tell me what you get. Now this one's not as tricky, but just about everyone's gonna get the right answer. But the problem is I'll just go ahead and work on it. I'll give you like 10 seconds to think about it. What is this problem once we evaluate it? So almost everybody gets this right. The answer is 4. But the problem I usually get with this one is I say, okay, well, how did you get 4? And I'll usually have one or a handful of students that say, well, you add the top numbers first, which is true. That is what you do. But you know what you just did? You did not follow PEMDAS. Because if I look at it, this is a division. That's what fraction bars mean. It means division. So why didn't you divide first? And then they'll be like, huh, no, I never thought about that. So why does it work? Why does it work that way? Well, because again, it says fraction bars. Fraction bars are a grouping symbol. Now, if you use computer programs like Microsoft Excel, if I wanted to write this into like a Microsoft Excel or any other program that's like that, or even some calculators, usually you would have to write something like this. And that tells the computer, hey, work on 4 and 8 first. That's what the parentheses would do in that case. But here we don't have parentheses. Well, they are there. We do group them. All right, so in that case, it's just like love. You don't see it, but it's there. Or I should say the power of friendship. So again, these are groups. Don't forget that. So again, that's why I like this one here. I like this GEMDAS. All right, it doesn't sound as cool, but that's pretty much true. Also, one last thing about addition, subtraction, paired with, so like addition and subtraction, it's the same thing. They are not different. They are, it's like the same car driving forward and driving backward, okay? It's the same car. They are not different. They are not twins. They are not opposites. They are the same thing. So that's why yesterday when I was talking about opposites and inverses, I mentioned that they are not exactly the same thing. Same is true with multiplication and division. One goes forward, the other goes backward. They're not opposites. They're not two different things coming at each other. It's like having the same car driving backward and forward. They are the same operation. So you can't say do multiplication before division because they are the same thing. And I think that's one thing that a lot of math teachers never really explain is that it is the same thing. All right, it's just like anything else, all right? Just because you change the direction doesn't mean it's an entirely new object. So let's go ahead and get onto the exercises now. So that was enough of that, and kind of a bit ranty, but oh well. It's one of those things that I think people need to really clarify that, again, same thing. I don't want to go on too long. So let's go ahead and simplify some of these. So again, this is the in-class work, so let's just start working on some of these. Now, I'm gonna do this a little bit faster. I think some of you guys are pretty good at this already. So I'm gonna end up having to combine a few steps together. And one rule is that the addition and subtraction is the last thing you do. So if something is separated by a plus or a minus, you can work on everything before that, as long as they don't interfere with each other. So that's what's gonna happen. I know there might be some people who are confused, but there's a problem, and that is if I'm using my whiteboard, I can easily just write it out each step, and the writing doesn't take that long. But when I have to use my mouse, it's a little bit longer, and if I try to speed it up, it doesn't quite work out. And I have to, it's gonna go a little bit, if I speed it up, my handwriting gets worse, and also my hand kind of gets tired if I have to do this all day. But I have to work with what I have. Anyway, so I have 2 to the 3rd power here. So 2 to the 3rd power, that is 2 times 2 times 2 times 2, which is 8. Oh, yeah, and I have a parenthesis here, but I have to work inside the parenthesis first. So I should do that first, but like I said, I am going to work on things that are separated by pluses and minuses. So I can take care of this at the same time without interfering with what's going on over here. So sometimes if you do something out of order, it can affect everything after that. But again, pluses and minuses are the last thing you do, so you can kind of work in between them. All right, so now next thing we got to do is take care of this parenthesis now. So again, in the parenthesis, I have two operations, exponent and a subtraction. So I still have to take care of them. So when you have a group or parenthesis, you still follow the order of operations inside, and then when the parenthesis is done, then you move again to all the other stuff on the outside of the parenthesis. So in this case here, sometimes we keep the parentheses, sometimes we don't. And for this one here, we don't really need it, but I'm going to show you what happens. So 11 minus 8 is 3. So again, I don't really need it, but sometimes you will need them, especially if you have a number, like just as an example, something like this. Because remember, parentheses can also mean multiplication, which is something that kind of happens too with I've seen this happen with students. Is there'll be something like this where there's a parenthesis and they'll be like, ooh, that's a parenthesis, I got to do that first. Even though it's not a grouping symbol. It's not a grouping symbol. All right, it's a multiplication. So anyway, I can take care of this one too. So 36 divided by 4 would be 9. Because 4 times 10 is 40. Subtract 4, you're reducing one factor, so that's 10 to 9, and you get 9. All right, now we have the subtraction. Now these are kind of just sort of in the way. They don't really do anything, so I'm gonna just get rid of them, even though I told you I was going to, but I'm just telling you that you should check them first. Check to see if those parentheses will cause anything to change. So let's go ahead and go 29 minus 3, so that'd be 26. And 26 plus 9 would be 35. And we are done with that one. Let's go ahead and box that up because we are done with it. All right, now we're going to go ahead and go to the next one. Now this next one here, it does have absolute value symbols in it, which on my slide, I showed you that absolute value is considered a grouping symbol. So if you see that, do that first. But let's go ahead and work on this one here. So again, there's a plus sign here. So I can work on this and it won't interfere with this, sorry, a minus sign. But I meant to say a plus or a minus. But in this case, it's a minus. Now, 4 to the third power, 4 times 4 is 16, and 16 times 4 is 64, so 64. Now this minus stays. All right, there's gonna be a little bit of a trick here. This first minus stays, but when we use the absolute value, which if I ask students, what does an absolute value mean? I usually get something along the lines of, well, whatever you put in there becomes positive. Now that works. Okay, it is a true definition, but it's not really everything going on. But for now, I'll go ahead and just stick with that, okay? Whatever you put in there becomes positive, so -8 becomes +8. But in this case, there's already a negative on the outside, so it sticks back onto the 8. It's kind of like doing laundry. You ever do laundry and when you're pulling something out of the dryer, you drop it and it gets dirty again? You know, like maybe the floor is dirty or there's something on the floor that shouldn't be there and you drop your clean clothes onto it. It's just sort of like that. So the clothes got clean, but there was something that made it dirty again. And let's see, I have a multiplication and a division. So I'm gonna just leave them all like that. Now here I have 3 of them, like I said, a multiplication and a division. So I should take care of these as well. Now I have to take into account that negative is on the 8, so that makes it a -8. So -8 times 6 is -48 divided by 16. So again, just because PEMDAS says multiply before divide, we still got to go left to right. So be careful with that, because if a division goes first, just like in that tricky example that I had, then you have to do the division first. There's also another way around this too, but it's kind of a more advanced technique, and that is to turn it into a fraction and reciprocal it. If you've ever divided fractions, you would know how to do this trick. But again, we don't really need to do this as long as you remember the rule to just go left to right. So 48 divided by 16, that would be 16, 32, 48. So about 3 times 64 minus 3. And we get 61. Not too bad. Okay, so I was gonna explain it later, so we wouldn't get into the, I wouldn't get you confused, but when you have an absolute value, the actual definition of absolute value is a number's distance from 0. So if you think of the number line and you think of, like, say 8, 8 is 8 steps away from 0, but -8 is also is also 8 steps from 0. Even though it's negative, distance cannot be negative. If you get in your car and you drive backwards 50 yards, you didn't go -50 yards, you went +50 because distance cannot be negative. So that's the more in-depth definition of an absolute value. So let's go ahead and get back to here. So 7 minus, now here I have a group with another group on the inside. So if you have 2 groups, start from the inside and work your way out. So 10 minus 12. So I end up with a negative number because I'm subtracting a larger number from a smaller positive number. Now again, there's a plus sign, so I'm going to work on this here too, and it shouldn't affect anything on the inside. So I got 25. And normally I would not do something like this, especially in the beginning of a class. I would not be skipping steps or doing what I'm doing now, but just because the writing is a bit of a hassle, I'm going to go ahead and do that anyway. But I think some of you guys are sharp enough. I think most of you would be pretty sharp to see what's going on. Now, 2 squared is pretty easy because 2 squared is just going to be 4. And I still got more stuff going on. So I need to take care of this. So I have a -2 in the absolute value. So that would become +2. And while I'm here, I can work on this whole thing in the parentheses. So +2 plus 25. So that's 7 minus 27, because again, 2 plus 25 is 27. And 9 minus 4. Now remember, the top numbers are also grouped. So there's technically 3 groupings on that top number. But we don't really need them because we kind of already know what to do. All right, so top number. Again, I'm having a small positive subtracting a larger number. And when that happens, your answer, or in this case, I should say, the difference will be negative. Because when you say answer, students always think that it's the final answer, which is why we don't call these, whenever we're solving an equation, we don't call it an answer, we call it a solution. Because something as simple as this, one step could be technically considered an answer. So like if I said 7 minus 27, well, the answer is -20, but it's not the answer we are looking for. -20 over 5, so divide that, we get -4. So just remember you're working with real numbers. If you have an integer, remember there's steps that you would have to use with multiplication and division. So if you divide a negative number by a positive number, you will end up with a negative number. All right, not too bad on that one. Let's get to this one here. 2 minus, and we have an exponent inside of this one. So again, we have an exponent and a subtraction. So we're going to take care of that exponent first. So 3 squared is 9. Plus, and I can take this one here because again, it's separated by a plus. So I'm going to go ahead and evaluate the square root of 81, which is going to be 9. And now I have some bottom numbers here. Now remember, this is a separate group. Top numbers and bottom numbers are grouped differently. So I can still work on them independently without having them interfere with each other. So I have a division here, so I got to do the division before the subtraction. So 10 minus, so 6 divided by 3 is 2. So I'm going to put 2 down here. All right, so we still got some stuff to work on. 2 minus 9 is negative 7. Negative 7 squared, so that would be negative 7 times negative 7. So negative times negative is positive, and 7 times 7 is 49. 49 plus 9 over, and then 10 minus 2 is 8. Okay, looking good so far. 9 plus 9 is 18. Carry the 1. And we get 58 over 8. Now, we should get into the habit of using mixed numbers. Or if you can, also reduce your fractions, because that is one of the things that is in our objectives. Simplify the answer as much as possible. So that's why we have the objective up there, so that way we can use it as a guideline to see how we should put our answers in there as well. So even though I know a lot of teachers go over objectives, they actually serve a purpose in that it kind of tells you if something like this happens, what exactly you should do. So we should simplify our answer, and that means simplifying the fraction as much as possible. Now with this one here, I'm going to start with division, because remember, that's what a fraction bar means. A fraction bar is a division symbol. So 58 divided by 8. Okay, so let's see. 8 times 7 is 56. And I'm going to go ahead and subtract that, so I get 2. So I'm going to turn this into a mixed number. So I can divide 8 into 58 times 7 times, but it doesn't fit nicely. It doesn't have a nice fit. We're going to have some remainder, a little bit of leftover. And your top number becomes, the remainder becomes the top number, and your bottom number is your original bottom number. So bottom number stays bottom. And here we are still not done, because this fraction is not simplified. We can reduce 2 and 8 because they are both even numbers. So that's what I'm going to do. I'm going to divide 2 by 2 and 8 divided by 2. So I get 7 and 1/4. Now, the reason I do that is because sometimes it makes more sense to put your answer in a mixed number. Like if something is 7 1/4 inches, you don't say it's 58/8 inch. That makes no sense. But if I was describing to like a carpenter, you know, we need a board that's 7 1/4 in length. That makes a lot more sense rather than saying 58/8. All right, you don't need to complicate things more than they need to be. Or in this case, I would imagine most students would just use a calculator and say 7.25. Oh well, it works. But not all numbers, not all fractions can be shown in decimal. And I'll show you an example later I have in this lesson. All right, I think these are going to be the last on this page here. Yeah, so we only have these two, and then we're going to move to a different kind of exercise. Now, these are supposed to be brackets, and I looked on the packet, and when I looked on the packet, they look like what we call the rounding down symbol. Basically, you just round the answer down. If it turns into a decimal, you round it down to the nearest whole number. So if something is like, say, 5.8, you round it to 5. So when I first saw this, I got confused, and again, it's on the packet too. So don't worry about this one. I'm just going to go ahead and remove that one. So if you are here now, just go ahead and mark that off and put attended the Zoom. Yeah, it's really just more that I got mad that that question didn't look right. That's the reason why I'm removing it. Plus that too, now that you're here, you can just put that in there. Or you could probably also just say you watched the video or something like that. And that tells me who's watching the videos too. So that way, when I'm grading papers, I can say, oh, look, hey, that person's been watching, the lessons. And I did that too yesterday, so that way it kind of helps out. So again, it's more of an incentive to get people to actually show up to the lessons. Let's go ahead and move on to number 6 now. So 9 minus 15. So it's going to be a negative because I have a larger negative, right? Negative 15 is larger. Now that's larger, not greater. So this would be negative 6. Now be careful with this type of problem here. This is why we need to keep the parentheses. Remember, I told you whenever you work inside of a parenthesis, you should ask yourself, is that parenthesis necessary? Let me just give you a really, really quick example. Let's say I have negative 7, like that, squared, and I have negative 7, like this, squared. On my top one, I am going to get negative 49. On my bottom one, that negative is included in the group. So that's negative 7 times negative 7, which is positive 49. So again, whenever you run into those parentheses, make sure that you keep them in place until you're sure you don't need them. So if I did not include this parenthesis, we might have ended up with something like the top answer where we end up with something negative. All right, so let's go ahead and take care of this one. I feel like I can take care of this one pretty easy. So this is just 7 minus 4. 7 minus 4 is 3. Because that 2 square, okay, like that's like the simplest number to square. And now we have 49. So square root of 49 is 7. And 5, so we took care of that radical. Minus, and again, we run into the same thing where we have a minus of an absolute value. So this one becomes positive, but this one makes it to the next step. So again, it's just like cleaning your laundry and putting it on the clothesline and it blows off and it lands in the dirt. Now your garment is dirty again. So let's go ahead and keep going with this. Negative 6 squared. So that's negative 6 times negative 6. Negative times negative is positive. 6 times 6 is 36. And let's go ahead and work on our bottom part here. 7 plus 5 is 12. Okay, I'm running out of space to write here. Usually when I move a step, I'll put an arrow here just to show that it's different, because if I just wrote it again here, it might look like they belong together. Although I don't think that's a big issue. So 3 times 6 is 18. Carry the 1. 3 times 3 is 9 plus 1, which is 10. So I get 108. All right, it looks like I'm going to have to write another step down here. I'm trying to write them with enough space so that way they don't get mixed or confused together. So 108 divided by 12. So let's think about that. 12 times 10 is 120. And if I subtract 112, that's reducing one of the factors by 1. So 120 minus 12 is, well, 108. So this tells us that the answer is 9. Or the answer from this one, what I should call the quotient. The quotient from here is 9 minus 5, because we're still subtracting 5. 9 minus 5 in this case is 4. And we are done with that one. Okay, let's go ahead and move on to the next type of exercise. One good thing about having the packet is that we don't need to spend so much time writing the problems down in a notebook. So you basically have a set of notes to yourself, although now that I think about it, that's not a really good idea, because if you're not holding on to the in-class work, then how are you going to keep them as notes? Well, anyway, I did that a long time ago at another school I used to work at. I would have the in-class work, so you'd put that in your notebook, and I would check it at the end of the year to make sure that you were taking notes. But it's not going to work with what we have going on right now. All right, so now what we're going to do is we are going to work with substitution. Now, it does not say substitution anywhere in your document, which is kind of a weird thing because substitution should be one of those vocabulary words that everybody in math should know. In this case here, they call it replacements or variable replacements. So, but again, the actual word that you should be using is substitution. So we're going to replace or substitute. I'm going to use substitute. That's the more appropriate word. We're going to, now I'm confusing myself. And I'm trying to call it one thing, but okay. So A is substituted with 3. And B is -4. Now this is another example here of taking the parentheses and putting them in the right spot. So B is -4. Now you might think, well, can't I just put -4 like this and square it? But again, that negative belongs with the 4. So when you replace it, so just draw a parenthesis around B, take away the B, and then put in the parentheses. So like in this case, this number is bringing its own negative with it. So that's why we end up with the negative on the inside rather than the outside. So we're not going to end up with anything different because we got to keep things the same. We got to keep things consistent. That's how we get math to work out, to keep getting the same answer each time. And here we have C equals 8, so 8 plus 12. So there we go. We plugged everything in, and let's see what we get. 3 times, and then -4 times -4. So again, it's squared, so that would be 16. And 8 plus 12. We can take care of that. 8 plus 12 would be 20. Now we have a multiplication and a division, but we are going to take care of the multiplication first, not because it comes first in PEMDAS, but because the top numbers are grouped. So 3 times 16 is, let's see, 16, 32, 48, I believe. 48 over 20. And we end up with another improper fraction. An improper fraction is the one where the top number is larger than the bottom number. When that happens, we divide it. Now, in this case here, we could use that division bracket that we used earlier, but in this case, I'm just going to go ahead and do it in my head. So 20, 40, it fits in there 2 times without going over. So 2. And again, your bottom number stays the same. And remember, we counted to 40. So 48 minus 40 leaves us with 8. Or again, too, you can just draw the division bracket and work it step by step. But if we look at our fraction, it is not in simplest form. So you might be thinking, okay, well, they're both even, so let's go ahead and divide them again. So divide it in half, and we're done. Whew, that was easy. No. We can go further. All right. So you may have remembered a time when somebody told you to clean your room, and so you just sort of throw everything in the closet. That's kind of what this is like. You did something, but it wasn't enough. We can go even further. Now, if you were paying attention to your greatest common factors, you would notice that you could divide 8 and 20 by 4. And you would have gotten to this step here. But let's face it, you probably would have done this anyway, and I probably would do it as well. So keep an eye out and make sure that you simplify it again. So we're going to divide them both by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. So 2 and 2/5 is what we end up with in this case. All right, let's go ahead and move on to number 8. So I'm going to replace m with 2 and n with -3. And I'm just going to switch the vocabulary between replace and substitute. I don't know if that'd be confusing or not. But again, in most math books, most math classes, they use substitute rather than replace. But I think it's just because this is a lower level worksheet. I think they're just sort of expecting everyone to not really use the right words just yet. Ooh, almost forgot the square. Yeah, there we go. Let's see, double check ourselves. So 10 times 2 is 20. And again, it's separated by a minus sign. So I can go ahead and work on this side here. I'm going to work on the exponent here. So again, the exponent is on the inside of the parentheses. So that means -3 times -3. So negative times negative is positive, and 3 times 3 is 9. So there we go. We took care of that. So 20 minus, and again, this is -8 times 9. So that would be -72. So 20 and -72. We run into the same thing where we have a small positive number and we're subtracting a larger number. So look at the number. In this case here, it's the bigger number, not greater, but the bigger number. And I'm going to go with 72 minus 20, which is 52. But I know my bigger number has the negative, so that means that in the next step it's going to be negative. Not that it really matters all that much because we're taking the absolute value of it. But since we have -52 and we take the absolute value of that, we are going to end up with positive 52. And that 5 kind of looked like a different number just for a second, so it's going to bug me a little bit. And there we go with that one. Now, I don't think I had enough time, even in my other class, to go over all of the problems. Most of these are pretty simple. I don't see very many issues with them, but there are at least 2 of them that I would like to go over, and that is number 10 and number 14. I don't know if I'm going to have enough time to go over all of them. Again, I'm trying to keep these videos a nice length of time that is watchable. Maybe if we have time, we'll come back and do some of these, but in my first hour, we weren't able to go through all of them and keep it under time. So let's go ahead and, again, jump over to number 10. So here I have R, that is 5, so 3 times 5. And again, this parenthesis is not a grouping symbol, so you don't do it first. Well, you don't do it first because it's a parenthesis, but in this case, you know, if it's a multiplication and there's nothing else above the multiplication that you're supposed to do, then you can do it first. 4 times S. Now, this one's a weird one because we have a fraction. And if there's anything I know about teenagers, it's that they are less scared of zombie apocalypses than they are of fractions. You tell them, ooh, there's zombies in town. They'll be like, oh yeah, where's it at? Come on, bring them on. But you tell them there's fractions. All right, that's pretty much the response I always get. So let's not be scared and let's do this. 3 times 5. There you go, 15. And just like yesterday, remember yesterday we learned the identity property, and that is doing something that doesn't change the value. So timesing something by 1 doesn't change it, and dividing something by 1 does not change it either. So I can put 4 over 1 and it doesn't change the value, but it does make it easier for me to multiply a whole number to a fraction. Now they are both fractions. This makes it a little bit easier to work with. Now this one's a bit of a tough one. This is why I elected to do this problem here. 15 minus, and then 4 times 2, so multiply the top number, multiply the bottom number, so 4 times 2 is 8, 1 times 3 is 3, and we end up with something like this. Now, if you type in 8 over 3 into a calculator, you would get something like 2.66666 repeat. And there's a problem with that and decimals is that when you run into a repeating number, you can't really work with it, because if I said, what is 15 minus 2.666666? Okay, you could round it off and come up with an approximation, but some numbers just don't have a number that has a decimal equivalent that you can work with. So in this case, we have to work with fractions. And I also, I don't remember if I mentioned this in this particular class, but I am also a teacher at the college here. So I teach college level as well. And I run into students all the time that cannot run fractions. They cannot do fractions. And you know, there will be fractions for the rest of your life. So I mean, assuming that you're not just like working, you know, some 7-Eleven counter or something for the rest of your life. Especially if you're a carpenter. So that's exactly what I'm gonna put here. So like I said, most of what I know about fractions, I learned from Mr. Windmiller, his carpentry class, which he's still around. Maybe I'll have him guest star in an episode one of these days. So there's two options we can do. We can either convert both of them to fraction notation, but since I said I'm going to use a carpentry example, let's say we have a 15-foot pipe, 15-foot board or whatever, and we need to remove 8/3 of that. Okay, so that doesn't make a whole lot of sense, but if you think about it in terms of feet, that's about, well, okay, let's see how many feet that would be. So 8, right, goes into, or 3 goes into 8 2 times, and I already said that it was going to be 2.6. Bottom number stays the same, and I have 1 left over. So 1/3 of a foot is 4 inches. So if you take a foot, that's 12 inches, divide that by 3, you get 4 inches. So yes, this is a perfectly good example to say a board can be 2 feet, wait, what did I say? 2 feet, 4 inches. So if I have a pipe that is 15 and I minus 2 and 1/3 from it, so we saw that off. Well, now here's where it gets a little bit tricky, because this is the way you're supposed to do it. I know some people would say, well, wouldn't it be 13 1/3 or something like that? No. I'm gonna borrow, because that's what you do. If this was a decimal problem, you would borrow. If you had $15 and you run into a vending machine and it says to pay exact change, you would run to a cashier and say, can I get some coins from this? That's exactly what you would do. So saying 15 and 14 3/3 is the exact same thing. There's 15 in here minus 2 1/3. And this is, like I said, this is the reason why I want to go over this problem here. So 14 minus 2 is 12, minus, and then 3 minus 1 here, and 3, and that bottom number doesn't change. When you're adding or subtracting, that bottom number does not change. So there we go. We have our answer. And if we saw a board that is 15 feet long and we saw off 2 feet 4 inches, we are going to have 12 feet 8 inches left. And like I said, this one is a really tough problem. We got to pull all the tricks in the book on this one here. And let me look at the homework. I think there are some with fractions, but I don't think they are this bad. There's number 14 on the homework. But even though it's a pretty bad problem, it is not as bad as this one. This one is one of those ones, like I said, we have to pull all the tricks out. So if you didn't get this one, or you don't fully understand it, that's okay. That's pretty much normal. I would imagine most people didn't really get this one. So like I said, that was one of the ones that, or I think there was one more that I wanted to go over, and that was number 14. Is it number 14? Okay, so this is another one that has a fraction. So I'd like to do all of the problems on the in-class assignment, but let's keep it nice and short for this. And most of these are pretty easy. But again, these ones with the fractions, I know these are always the ones that people have trouble with. So let's go ahead and replace m with 1/4. Now, sometimes you can have 2 variables that both require a replacement. So we replace m with 1/4, and we also replace this m with 1/4. So now I have 2 fractions. But this one also has something a little bit different too. This is I don't know if there's any more of these. Let me look over the assignment again. And I don't see any other fractions that have a power. So there's probably a good chance this may be the only one we have. A fraction with a power. I'm looking through the homework. I don't see any. So again, this is another one of these problems that probably only will appear here. So let's go ahead and take 1/4 and square it. So this means 1/4 times 1/4, or 1/4 of a fourth. Now, if I say it like that and you're thinking, I think I have an idea, you might be on the right answer, but let me show you how you do this one here. Square 1, so 1 times 1 is 1, and square the bottom number, which is 4. So 4 times 4 is 16. Plus, and here I have another 1, so I'm going to put a 1 under this just to make it easy. 9 times 1, and 1 times 4. So I end up with 9/4. Now, I would like to turn both of these into mixed numbers. Because I understand that it is pretty confusing. But I'm going to go ahead and evaluate this one here, 2/16, so 2/16 plus 9/4. Since they're both in fraction notation, I'm going to leave it. So you might be thinking, well, can I turn this into a mixed number? Hold on right there, okay? We need them to be in the same notation. So if they're both fractions, let's just leave it like that for now. So, darn. Okay, so I have two choices here. I can either make this one smaller, and it would be 1/8, but I would still not be able to add this one on there because the bottom numbers need to be the same. We need to have a common denominator. So what I'm going to do is I am going to convert both of these into a number with the 16 on the bottom. So again, this is something that's a bit of an advanced thing. So I'm going to times this side by 4/4. Now, if you remember identity property, if you multiply a number by 1, it does not change the value. 4/4, any number divided by itself is equal to 1. So I'm using two number properties to get this problem. So if I multiply 9 times 4, that would be 36. And 4 times 4 is 16. Now, if you have a calculator handy, type in 9 divided by 4. You should get something like 2.25 or something like that. And if you type in 36/16, you get the exact same number. You did not change it. You just changed what it looked like. And again, this is something that I have trouble teaching to college students, but I don't know why that is. You know, if you put a hat on in front of your dog, they're still going to know who you are. You know, it's not like I know there's a cartoon that does this. But actually, no, there's a lot of cartoons that do this. Like, you know, Superman or like Clark Kent takes off his glasses. Oh my God, that's Superman. Or like Perry the Platypus puts on a hat or something like that, and he's immediately recognized. So be careful, because that is something that especially happens in fractions. You can get two things that look different, but actually mean the same thing. But anyway, now we can go ahead and reduce this. So 16 divides into 38 twice. So 16 times 2 would be 32. 38 minus 32, so that's going to be 6/16. And again, reduce this fraction. So 6 and 16 can both be divided by 2. So divide this by 2 and take that and divide this by 2. So there you go. And like I said, this one is an exceptionally difficult problem, and there are no others in the homework or in the in-class work that are going to be this difficult. So let's move on to the next type of exercise. So we're going to have to use our principles of, gosh, it's on the poster right here. It's I call it the rules for evaluating or solving. There you go. That's what it is. So if you've ever wondered what this poster is in the background, that's exactly what it is. But I know you can't see it from here. So let me go ahead and just go over it. And that is going to be combining like terms. So in this case here, 16 minus 7. Okay, that shouldn't be that hard. So we're just going to combine the ones that have the same letter. So 16 minus 7 would be 9. So 9x. And regular numbers. Regular numbers are considered like terms. Well, we call them constant values is the word that we have. So let's add the constant values together. So that would be minus 1 because negative 11 is bigger than positive 10. So our answer is going to be negative, and 11 minus 10 is 1. So we get 9x minus 1 here. And let's go ahead and use this one. So this one is going to be a distributive. So I know a lot of teachers would usually point out that you use distributive, which is what we learned yesterday. Well, you didn't learn it. You probably already knew it. I should say we reviewed it. So times this by 2 times negative 7 by 2. And these are pretty quick. They're pretty easy. I really shouldn't have to go over all of them, but they're way easier than the last one, or I shouldn't say easier, but they're faster to work with. So 13, oh, actually, no. When you're working with algebraic expressions like this, you use what's called descending power. Okay, you don't need to know what that means, but basically letters go first. So in this case here, I get 6 plus 19, which is 25n. Now we work with our constant values, minus 1. So 25n minus 1. So that's the answer for that one. Let's go ahead and box that up. Like I said, not that tough. Let's look at some of them that will be tricky. So this first one here is not too tricky. We just multiply both of the numbers in the group with 6. So 6c minus 12. Now this is the one that's tricky. If you remember when we were solving radical expressions, this was one of the ones I said, you gotta know what this is. And that is, if you have a negative in front of a group, flip the signs of everything in that group, because what's happening is you are minusing that whole group. So this 8c, you're minusing that. This number 1, you are minusing that also. The whole thing is being minused. But again, the trick is just to reverse the sign of everything in the parentheses. From here, you can go ahead and combine the c values, 6c and 8c. So minus 8c, you get negative 2c. And remember, when you have two negative numbers that you are combining, you make them into a bigger negative. And that's it for that one. But again, there's just that one small trick you got to worry about, because like even when I'm grading papers, no matter what level I'm teaching, I always see that. Just in the interest of time, I'm going to leave out number 18, but I don't see anything really tricky with that one. Should be fairly straightforward. So like I said, I'm really just looking for the ones that are the tricky ones. So I'm going to jump to 19 and 20, and this will be our last slide, and we will be done after this. So again, distribute. Use our distributive property. 3 times 3 is 9. And we have the a, so there you go. And keep the sign, be careful, because this is 3 times negative 5, so that'd be 15b. And we run into the same kind of problem here. We are subtracting this whole group. That means this a is being subtracted, and this negative is being subtracted. Now remember, if you take away a negative, it becomes positive. So that's what's happening. Take away the negative, so that's why we have 7b. Or again, just reverse the signs of everything on the inside. Combine your a values, 9a minus, well, 1a, because remember, if you don't see a number in front of a variable, the coefficient is to be 1. Now we have a negative number, so my negative number is bigger than my positive number for b, so it's going to be 8b. So negative 8b. 7 minus 15 is negative 8. Or again, we know it's going to be negative. 15 minus 7 is 8. That's probably the easier way to do this, is to use what we call the absolute value. Oh, hey, what do you know? We already covered that earlier in this lesson. What we call subtract the absolute value, meaning that most people don't usually do what we've done and minus larger numbers from smaller numbers. With enough practice, it becomes pretty easy to do. But I know when some people are starting out, or if they're not very good at it, it's helpful to kind of reverse them and then look at the sign. All right, last one. So let's go ahead and multiply both of these by negative 8. So that's negative 16x. Again, whenever you have a negative, even if it's on the outside with a number, wherever that 8 goes, this negative goes with it. That negative is part of it. That's not a minus 8. That is negative 8. So it goes with it. Everywhere the 8 goes, that negative is going to go with it. Same is true with this one here. That is not minus 3. Well, it looks like minus 3, and you could argue that it is. But you think of it as negative 3. So everywhere that 3 goes, that negative goes with it. So 3 and 5, like this. Negative times negative is positive. 3 times 5 is 15. Throw on the x. Same thing here, negative times negative. So that means this will become a positive value now. 3 times 2 is 6. And there's only one variable, so it stays on. Now we can go ahead and combine our like terms. 15 minus 16 would be negative x. It'd be negative 1x, but again, 1 times anything does not change the value. That's the identity property. So again, you use these properties all the time. You just don't know you're using them until I pointed out to you that right there we are using identity, because 1 times a number is just going to be that same number, so we don't need to put it in there. And 6 minus 8 is negative 2y. And there you go. So that looks like we are done with the packet for the in-class work. So there you go, 5 points. If you've been following along, that's 5 points. Well, there's like 4 of them that we missed, right? We skipped a couple of them, but I think you guys are pretty sharp. You should be able to get those on your own. But yeah, 5 points, easy attendance score. The only thing you'd have to do left is your homeworks, and that's it. That's 10 points. So that's it for today. I'll be around if there's any more questions, but if not, then that's it. I will see you later tomorrow. Bye.